Hello बच्चों. Now today we are going to discuss about the resolution of forces. Okay, resolution, resolution of forces. Okay, so what is the meaning of resolution? So we are actually you are familiar with the vector resolving of a vector along the x-axis and along the y-axis. Okay, so let us suppose this is a axis, here it is x-axis and it is y-axis, and there is a vector, that is a is a vector. So the component of a along this x-axis, if this a vector makes an angle of theta, so this will be the a cos theta and this will be the a sin theta. Okay, but when it is happen, when the angle between these two axes is 90 degree. But what you think, or what you know, or what should you know about that? If the angle between the 90 degree, then the story is totally different. Okay, so now if suppose there the vector, this is the vector arrangement, or this is the axis arrangement, and here it is a vector or maybe a force, that is r. Okay, and p is the horizontal force and q is the vertical force. So how can you resolve the force r along x-axis and along y-axis? Not necessarily x or y-axis, but it is an arbitrary axis. Maybe it is x, y, z, or any axis you can assume by yourself. So how can you resolve? So if let's suppose this is the angle alpha and this is the angle beta. Okay, so if there are three forces which is acted at a one point, then the we can apply Lami's theorem. Okay, so Lami's theorem. So how can you apply Lami's theorem? So according to Lami's theorem, the force and the sine of angle between the other two forces. So if you consider the force P, then the angle between the other two forces, that is sine of beta. Similarly, Q upon sine of alpha and R upon sine of alpha plus beta, because when you consider R, then the force or the angle between these two forces P and Q is alpha plus beta. Okay, so now if you equate this and this equation, then you get P upon sine beta equal to R upon sine alpha plus beta. So what is the value of P? Here R sine beta upon sine alpha plus beta. Okay, and similarly you can also obtain the relation for Q upon sine alpha equal to R upon sine alpha plus beta. So what is the value of Q? So that is Q is R sine alpha upon sine alpha plus beta. Okay, so now if you want to check the validation of this relation, then you can simply assume that if alpha plus beta is 90 degree, then it should follow the same pattern what you observe here. Okay, so if you put alpha plus beta equal to 90 degree in this P and Q equation, then what is the value of beta? So beta is 90 minus alpha. So P equal to, that is R, and sine beta. Sine beta means sine 90 minus alpha. Okay, divided by sine 90 degree. So this will be R sine 90 minus alpha. Sine 90 minus alpha is cos alpha. So R cos alpha. And similarly, when you put the value of alpha plus beta 90 degree in here, so you get Q is equal to R sine alpha. Okay, so this is the resolution of forces. So how can you, now we are going to solve a single problem that is based on this resolution of forces. The problem is the resultant of two forces the resultant of two forces is 10 Newton and it is inclined at 60 degree to the one of the force, okay, whose magnitude is 5 Newton. Whose magnitude is 5 Newton. Determine the magnitude and direction of other two forces. Determine the magnitude and direction of other force. Okay, so now if you want to plot this figure, so let's suppose this is a two forces. Two forces. One is P, or one is 5 Newton, and resultant is 10 Newton, and this makes an angle of 60 degree. Okay, and let's suppose this force is Q. So what is the value of, not there is a vector sign because here we only assume the force. So Q is, you should determine the value of Q. So how can you solve this? So let's suppose this angle is alpha. So again you apply the Lami's theorem. So according to Lami's theorem, what happened? So 5 Newton, 5 upon sine of angle between other two forces. So sine of alpha, and Q upon sine of 60 degree, and 10 Newton upon sine of 60 plus alpha. Okay, so when you put 5 upon sine alpha and 10 upon sine 60 plus alpha, and you can you solve this equation, then sine alpha equal to 10 upon sine 60 plus alpha. So you can easily solve this equation. 2 sine alpha equal to sine 60 plus alpha. Okay, so this is a homework for you, or here you can solve by yourself, and you can get the value of alpha is 30 degree. Okay, so you can solve by yourself, and you see the angle is 30 degree. So when you put this angle 30 degree in this expression, that is, either you put in this or this, you can easily obtain the relation for the Q. So it depends on you whether you want to put. So here if you see here alpha is 30 degree, so alpha is 30, then you can easily put here, so Q upon sine 60 equal to 10 upon sine 90. So Q equal to that is 1, so 10 into root 3 by 2. So maybe it will comes out to be 8.65 Newton. Okay, so you can check by yourself. Now we are come to the next problem, and the problem is, that a force 250 is resolved into components of force 250 is resolved into components along AA prime and BB prime. oriented as shown in the adjoining figure. If the resolved component along BB prime equals to 125 Newton, what would be the value of angle alpha? Also calculate the corresponding value of force. Also calculate the corresponding value of force component along AA prime. Force component along AA prime. Okay, so how can you calculate? So let's suppose this is your A and A prime. Okay, and now let's suppose this another adjoint is, that is B and B prime, and there is a force that is 250 Newton. Okay, so let's suppose, and this angle is 45 degree and this angle is alpha. So you can also easily determine the angle this. So 180 minus 45 plus alpha. So now again, what should you determine in this equation? So this along BB prime is 125 Newton. So here the force is 125 Newton. So you can easily plot this is 125 Newton, this is 250 Newton, and this is the force that you have to determine. Let's suppose this is P. Okay, and this angle is alpha. This angle is 180 minus 45 plus alpha. Okay, so now I think you can solve by yourself, and the value of alpha is found to be 20.71 degree and P is 322.27 Newton. Okay, so now the next topic is how the resultant of coplanar concurrent forces. Resultant of coplanar concurrent forces. Okay, so how can you determine? So what is the meaning of concurrent force? So the concurrent force is nothing but it is the force which is acted. It is the force which is acted or which is act from the single point. Okay, so let's suppose this is your x-axis and this is your y-axis. So now let's suppose this is your P1, this is your P2, this is your P3, and let's suppose this is your P4, and the angle is, this is alpha 1, this is alpha 2, this is alpha 3, and this is alpha 4. Okay, So how can you find the resultant of coplanar forces? So in order to determine the resultant of coplanar forces, first you should find out the value of the total force acted along horizontally. Okay, what is the meaning by horizontally? Means you can resolve all the forces along the x-axis. So what is the value of forces along the x-axis? So for example, for the P1, it is P1 cos alpha 1. For P2, it is P2 cos alpha 2, P3 cos alpha 3 plus P4 cos alpha 4. So let us suppose this is your equation 1. And similarly, you can find the Fy. So that is P1 sin alpha 1 plus P2 sin alpha 2 plus P3 sin alpha 3, okay, plus P4 sin alpha 4. So this is equation 2. So how can you find the overall resultant? So you are already familiar with that. So if there is a vector r, okay, which is resultant of, let's suppose this is your r cos theta, this is your r sin theta, okay, and if it is alpha acted at an angle theta, okay, acted at an angle theta, so the resultant will be r square equal to r sin theta का whole square plus r cos theta का whole square. And if you apply this is not theta, this is alpha. So this component is not r cos theta. Let's suppose this component is fx and this component is fy. Okay. So you can simply found that this r equal to under root fx square or sum over fx square plus sum over fy square, and this angle you can easily determine by the tan alpha equal to fy upon fx, because in this angle this is your perpendicular and this is your base, so this is your fy and this is your fx, so the tan alpha is fy upon fx. Okay, so now here you see that you can find this r square equal to sigma, or already you put here square, so this is not sigma fx square plus sigma fy square. So r equal to under root sigma fx square sigma fy square, and the tan alpha is, or tan theta, maybe you can put anything, tan alpha is sigma fy upon sigma fx. So this is your equation 3 and this is your equation 4, and in this way you can find out the resultant of coplanar forces and the angle at which this resultant should be act. Okay, so now based on this formula we can solve a single. So that is only happen when you are considering the angle from the, when you are considering the angle from the x-axis. But if you want to consider the angle, let's suppose this is your forces, let this is your P1, this is your P2, this is your P3 and this is your P4. Okay, so let's suppose this is your angle alpha 1, this is alpha 2, this is alpha 3 and this is your alpha 4. Okay, x-axis, y-axis. Okay, so this is your x-axis and this is your y-axis. So how can you solve in this case? So there are again two points that you have to notice here. First point, you can make the angle from x-axis towards anti-clockwise direction, anti-clockwise direction. Okay, so means you can simply angle at the 90 degree here, 180 degree here and 270 degree here. Okay, so in that case how can you get? So similarly, you can get here sigma fx equal to, so P1 cos alpha 1, then P2 cos 90 plus alpha 2 plus P3 cos 180 plus alpha 3 and plus P4 then 270 cos. Okay, so here cos 270 plus alpha 4. Okay, so this is a one mode of calculation. In this way you can perform, but the another one is you should careful about the quadrant system. Quadrant So do you know about the quadrant system? So in quadrant system, let's suppose this is your first quadrant, this is your second quadrant, this is third, and this is fourth. So in first quadrant, both the quantities should be positive. In the second coordinate, the x component or the horizontal is negative and the vertical is positive. In third, both is negative. In fourth, the vertical is or the horizontal is positive and vertical is negative. Okay, so now here you see that this alpha 1, if you consider the component of this P1, so the component is along this axis, okay, and along this axis. So how can you write in this case? So sigma fx A is equal to, so here if you see here, this is along first quadrant, so the both the quantity is positive, so here you get the P1 cos alpha 1 and here you get P1 sin alpha 1. Okay, now here I can put the another color for the P2 because otherwise you can confuse. Okay, so now we put green for the P2. So for P2, so this is your P2 cos alpha 2 and this is your P2 sin alpha 2. Now for P3 we can take color as a blue. So this is again P3 cos alpha 3 and here it is P3 sin alpha 3. And now for dark blue, you can use dark blue for P4. So this is your P4 cos alpha 4 and here it is P4 sin alpha 4. Now we take the quadrant. We take care for the quadrant. So in this case, so what is the value of P1? First we consider only the horizontal component of the forces. So P1 cos alpha 1, this is positive, and then along this axis, so P2 sin alpha 2, so that should be in negative, so minus P2 sin alpha 2. Now P3, so P3 is again negative, P3 into cos, so P3 cos alpha 3, okay, and now P4, so P4 is along positive axis, so that is plus P4 cos alpha 4, okay, and similarly you can write down for the vertical component, and for the vertical component, so this is a P1 sin alpha 1, okay, plus P2 cos alpha 2 plus, or you can check here, so P3 is in along negative axis, so minus P3 sin alpha 3 and minus P4 sin alpha 4. So in this way you can determine the value of horizontal and vertical component. Okay, have you understand? So there are 2 points that you should careful about this calculation when you find out the value of resultant forces. Okay, resultant coplanar forces. So now Now we are going to solve a single problem based on this. So the problem is that you have a hexagon, regular hexagon. Okay, so let's suppose this is your force, this is your force, and this is your force. So along this direction the force is 2 Newton, along this direction the force is root 3 Newton, along this 5 Newton, along this again root 3 Newton, and along this that is 2 Newton. So this angle is 30 degree, this angle is from here to here 60 degree, from here to here 90 degree, and from here to here it is 120 degree. Okay, so in this case you have to find the resultant and the angle. Okay, so how can you solve? So this problem I am going to solve. Okay, so now the first you can find the value of sigma fx. So fx is, since this is acted along the 0 direction, so this is 2 cos 0 root 3 cos 30 5 cos 60 plus root 3 cos 90 plus 2 cos 120. Okay, so when you solve this equation and you can find the value is similarly you can find the value as 2 into 1 root 3 into root 3 by 2. This is 5 into 1 by 2 and root 3 into 0 and 2 into minus 1 by 2. So this will be cancelled out, and here you get 2, 3 by 2, 5 by 2 and minus 1. So this will be 1 and this will be 5, 3, 8 plus 4. So I think this is 5 Newton is the resultant horizontal force. Similarly you can find out for the Fy. Okay, and you will get the value of resultant is 10 Newton and the alpha is 60 degree. Okay, so you can check by yourself. Now the next problem. So the next problem. So a right circular roller of weight W rest on a smooth horizontal plane. Smooth horizontal plane and is hold in a position by string AC as shown in figure. Okay, the roller is pulled by a horizontal force P applied to its center. Full stop. Find the reaction at B and tension of the string. Okay, so this is your horizontal plane and in which a roller is rest. Okay, so this is roller is rest. Okay, and from the center of this roller we applied a force P and which is held by a string AC, and this is your point B. So we should find the value of reaction that is passes through this center of gravity or the center of roller is R. Okay, so let's suppose this is your angle alpha, and since you are apply the force on this roller along the right hand side, so the tension in the string will be generated along the left hand side. So if this is angle alpha, so then what should be the value of this? This is also alpha. Okay, alternate angle. When two parallel lines and one straight line is crossing in this way, then using the alternate angle, you can find the value of these two angles is equal. Okay, so now here you apply the you can make a figure. Okay, so the figure is that here it is P, so here it is a first, this is W, weight of the roller, and the reaction, that is R, and this is a tension T, and this is your angle alpha. Okay, so this will be your T cos alpha, and this will be your T sin alpha. Okay, so now you can compensate, or you can make a comparison between the left hand component and the right hand component, and you get here T cos alpha is equal to P, and R equal to T sin alpha plus W. So when you apply, when you put the value of T from this equation 1 to this equation 2, you can get T as P upon sin alpha or cos alpha. So P upon cos alpha sin alpha plus W. So this is your sin alpha upon cos alpha is tan alpha. So P tan alpha plus W. Okay, so this is your R equal to P tan alpha plus W. Okay, so now this problem is over. One more problem, we can solve this problem in next class. Okay, so thank you.